So take this example. So we have in this case what happens is, we have two resistors R1 and R2. We have a current of 220. So we know that R1 plus R2 is equal to 22 ohms. So the current that will flow through this is going to be 10 here and 10 there, which is equal to, how did I get 10? It is 220, which is the voltage that we have out here, and it is divided by 22, which is the net effective row, and that gives you the amperes. Now let us see how we can go about solving a more complicated problem. So in this case what happens is, we have couple of them in series, and then we have these two in parallel, and then all of these are in series. So the way to do it would be to look at this circuit and see what would the effective circuit be. Effective circuit meaning that I will have to find out what is the effective resistance on this parallel branch, right? So you have so if you have 1 by 6 plus 1 by 3 is equal to 6, 2 plus 1, that is 1 by 2, that is therefore implies the effective resistance of this piece is equal to 2 ohms. Now let us see. So if you come out here, what you are essentially getting to see is that the effective resistance in this circuit is shown as 2 ohms. So now we have essentially reduced it to a serial circuit, right? So in the serial circuit what happens is, we have 17 plus 3 plus 2, that is 17 plus 5, that is 22 ohms. The voltage out here is 220. So the effective current is going to be 10 amps. So we'll have 10 amps going here, we'll have 10 amps going there, and we'll have 10 amps going there. Now what we have to actually go back and explore is, how does this 10 amps get transmitted, gets divided into these two branches. So now we know that we have 10 amps coming here. So how will they be broken up? So the way that we know is that, given that the voltage between this point and this point is exactly the same, right? And what is voltage? Voltage is equal to R into I. In this case it's going to be 6 into I1 is equal to 3 into I2. Therefore I1 upon I2 is equal to 3 upon 6, or equal to half. That means the 10 amps which is going here, the 10 amps will now have to be broken up into 3 parts, right? One part will go here and 2 parts will go here. So you assume this is going to be 3.3 and this is going to be 6.6 amperes. Alright, and this we are using the normal property, proportion and ratio problem that you must have done in your maths class, right? So how do you divide the 10 amps into 2 parts in ratios of 1:2? Obviously the one with the lower resistor will have the higher current, the higher resistor will have the lower current, to make sure that the multiplier is exactly the same. That in essence is essentially covers this extension to Ohm's law class that we talked about.